Hi there, this is going to be a short video on some examples that would consider to be under the topic of multiplying with complex numbers. I'm going to run through a few that you might see in your problem set so that you can have a model for each different type. The first type that you might see would be something like the following. Negative 2i times 4i times negative, let's do 11i. So these are three imaginary numbers that we have to multiply together. And we're going to treat the I almost like a variable, It's not a variable, but we're going to treat it the same way when we do our multiplication. So I times I is I squared, I times I is I cubed. We don't add the i's together, we actually do the multiplication and end up with exponents. So in order to multiply little monomial imaginary pieces, we multiply all the coefficients together. So the negative 2, the 4, and the negative 11. That's going to give us, I believe, negative 2 times 4 is negative 8 times negative 11 is positive 88. And then I times I is I cubed. However, we know that I cubed can be simplified. We learned that I cubed is equal to negative I. So we're going to make the translation that this is going to become negative I, and 88 times negative I will be negative 88I. That's our final answer. So not too tough in that respect, but what happens if I threw in, what if I gave you 6i times the quantity of negative 3i squared? Now, we should remember from our previous algebra class that anything with powers we're going to do first. That works with the order of operations. So I'm going to focus on this negative 3i squared. Negative 3i being squared really means the following. We've got the 6i that's there. It means negative 3i times negative 3i. We're taking each piece and raising it to that power in there. Because it's only to the second power, I can write it out next to each other. The way that I did here, it's not too time consuming. So if you feel comfortable doing that, that might be a good way to go. So we multiply all the coefficients together. So that's 6 times negative 3 is negative 18 times negative 3 is 54, I believe, and it's positive. We could have done 9 times 6 and gotten our 54. And then I times I again is I cubed. We know from the problem that we just did, we ended up with another I cubed. I cubed is equal to negative 1 or negative I. And that means that our final answer will be negative 54i. So that's an example where you might have an exponent involved. Another type of multiplication problem that you might see is one that might look like this. The quantity of 3 minus I times the quantity of 4 plus 7i. Now this is the product of two complex numbers, and we treat it just like we're multiplying two binomials together. So we're going to use that FOIL approach. We're going to multiply the first terms, which give us 12, times the outer terms, 21i, multiply the inner terms together, negative 4i, and then multiply the last two terms together, and this is where we need to be a little careful. We get negative 7i squared. When we get to this point, we want to look to combine like terms and simplify any powers of I. So my i's go to two different places, here and here. We can combine 21i minus 4i to be 17i. And we know that I squared is equal to negative 1. This becomes negative 7 times negative 1, or just positive 7. So when you see that I squared and it's getting multiplied by something, you could immediately say it becomes positive, or it changes sign, I guess we should say. So this will give us 12 plus 7. This is plus 7 over here, which is 19 plus 17i. Final answer. We want to make sure all of our like terms are combined. We want to make sure all of our powers of I are simplified. What if I gave you something like this? 2 minus I times 2 plus I. Very similar type of problem, except for the fact that we notice something is going on here. We have the same first terms, we have the same last terms, and the signs in the middle of our complex numbers are different. We talked about the fact that these are called conjugates. And when we have conjugates, we know that, whoops, my pen is off. We know that the middle terms will drop out. So technically with FOIL, we just have to do first and last. If you don't remember that, you can do the entire FOIL and you're going to notice things are going to drop out. But if you remember that, it's going to give us just the first terms are going to be 4. The last term's negative I squared. We know that I squared is equal to negative 1, but it's getting multiplied by the negative sign, so this turns into positive 1, which means that we end up with a value of 5. So the product of two complex conjugates always gives us just a real number in the end. The last one I'm going to do here is something like the following. The square root of negative 12 times the square root of negative 5. We're taking the square root of two negative numbers and being asked to multiply them together. You have to first pull the i's out. So what that means is you've got to write this as the square root of negative 1 times the square root of 12 times the square root of negative 1 times the square root of 5. So it's these two pieces getting multiplied together. The square root of negative 1 is equal to I. The square root of 12, we have to think about that. That's not a perfect square, but there is a perfect square within 12. That's going to leave us with, I believe, 4 times 3. So that's my first grouping. The second grouping is going to give me I. And the square root of 5 has no perfect square in it, so I'm going to leave it as the square root of 5. The first set of parentheses is going to become I times the square root of 4 times the square root of 3. The second set of parentheses I really can't do anything with, so I'm going to leave as I times the square root of 5. I can still simplify the first set of parentheses into, you notice I dropped my parentheses and it's okay at this point in time. The square root of 4 can be simplified to this 2I times the square root of 3 times I times the square root of 5. Now I have to multiply these together. I'm going to take anything in front of the square root sign, the 2I and the I, and multiply that together. That leaves me with 2I squared. And then I'm going to multiply the two positive numbers underneath the square root sign. The square root of 3 times the square root of 5 is the square root of 3 times 5, or 15. I'm going to look at my line now, and the only thing I realize I can do is the I squared is equal to negative 1. So this becomes 2 times negative 1. I can't do anything with the square root of 15 because there's no perfect square in there. If there was, I would have to simplify that. But my final answer now will be negative 2 times the square root of 15. That's a tough one because it's long. It's got a lot of parts to it. You may have to use this one as a model for some of the work problems that I give you to do. So hopefully this will help and let you be able to have some models for some of the problems that you have to do.